for 1153 and 1119. Drive coach for 1153, so if you ever are behind the class, you might see me there. If you go to events, I'm a game announcer in NEMC for First and First Global. So one of the senior voices in New England, so if any of your students or you're interested in getting up behind the microphone, let me know. And outside of doing robots, I'm a software engineering manager at Rapid7, it's a cybersecurity company. So I'm kind of moving into the manager people side of space. So it does mean doing a lot of things in spreadsheets, so get ready for some great screenshots of all this. And when I'm not doing robots here, I run a lot. I run a lot inside amusement parks and theme parks, and I go to a lot of Broadway shows. So there's some photos of me just looking at my desk all the time. So yeah, so just going over stuff. We'll go over what is the Walpole Robotics Program. We'll do a bit of history about how we got to having 2 FRC teams. We'll talk a little bit about how does our off-season work, how does our build season work, our competition season, what our future pipelines look like, how do we funnel students into the system, a little bit about finances on the running the 2 teams, and then any sort of party works.
Oh, perfect. There we go. So there's that. Please feel free to use this to interrupt me at any time as we go through to ask any questions that you have. We have this pretty intimate group here, so feel free to just shout it out and raise your hand, and I'll go from there. So what is in the Walpole Robotics Program overall? So we have some LEGO League teams. These actually started up in 2023. We'll talk through a little bit of that near the end. But we run these at our town library for a few different kind of reasons. We have 3 teams right now, but it is currently growing. It started off as like 1, then it went to 2, then it went to 3. Now I think we're going up to 5. So we're going to have a good pipeline coming through there. Additionally, we've got 2 FRC teams, 1153, which started in 2003, and the Pup Cups, who first officially started competing in 2024. So one of the first things people ask is, how big is your team here? So overall, we've got about 36 students or so who are on in the 2 teams. There are 8 seniors, 8 juniors, 7 sophomores, and 13 freshmen from last year, and 14 mentors. So kind of one of the big things I would say is you don't always really need a super large team in order to be able to run these 2 teams. A lot of teams, we've sort of discovered that you can kind of run a team off of 15, 16 dedicated students as long as they're supported with those mentors there. And so kind of what was the best way of kind of getting double bang for a buck was kind of going on that route. So quickly, let's take a look at what did where did we start from? How did we start kind of working things? We had some off-season trainings that a lot of people kind of do, where each discipline had a dedicated night. So if you want to come in on Monday nights, we learn software. Tuesdays would be electrical, Wednesdays CAD, Thursdays mechanical. And so students would have to pick what night I want to come in, and I'm just going to learn who my friends are and try and dive in on different stuff there. And it led to the team being very pillar-based. Everyone just sort of knew people who would be on their own sub-teams, and things were kind of fine. It works well, but it doesn't. It changes up a lot between the off-season and build season, and all of a sudden everybody's working together, and now you don't know who's there, and everyone's on top of each other's spaces. So when you hit build season, we try and do proof of concepts on top of the kit bot, figure out what works there. Then we built prototype robots, try and figure out what things worked well, it didn't work well, and then we turn all that into a competition robot, ready to go.
But you kind of run into some problems that we ran into that, some of the photos of our 2020 experience as we went there with our little Frankenstein. First steps are, newer students don't always know where to start. If you come in and you're just like, hey, you're going to start, come in, pick your favorite night, and you haven't been exposed to what are the different nights that you're going to. You're like, well, I don't know which one, so I'll just go where my friends are. So you're like, I'm not quite sure what's going with that. When you jump it up from one night a week to saying, hey, we're going to be in here 20 hours a week, meeting 3-4 days a week to build a robot, everyone's like, whoa, that's a lot of a time investment. I don't know if I want to dedicate that much to jump in here. As these Frankenbots point out, the only time we ever practiced integration or working together as a team was happening during build season. So we weren't always allocating space on the robot, allocating space in the machine shop, weren't really kind of getting things ready for people to work together. And one of my fundamental things you kept seeing is throughout a whole season, the robot's really big on kickoff day. It's filled with everyone's ideas, hopes, aspirations as it goes. And then as you start prototyping and building those robot functions, it just kind of keeps funneling down of like, all right, well, we're going to peel off and we're going to build the drive, or we're going to build this intake, or oh, we built a different kind of intake, and I guess I'll jump to some other sub-team where I'll know because these other people took on that system there. So we hit a little bit of a reset. I think a lot of teams kind of did at this point. So we kind of took some time over the course of Infinite Recharge at home. It hit fall 2021. Our school was opening up after school activities again, and we're just like, hey, what can we try and see? What can we kind of do as we go forward here? You're gonna have a year where we basically only had seniors on the team for the 2022 robot. We had 6 seniors. We had like 1 junior who kind of was floating around. No sophomores that kind of got recruited, and then we're gonna have a whole bunch of freshmen. But so we're like, okay, so we've got a lot of really experienced students who have gone through a lot or tried to stay engaged over COVID, but haven't had a chance to pass any of that knowledge down. But we could kind of see what a smaller, dedicated group of students could do. And we had built some EveryBot. Are people here familiar with the concept of the EveryBot? Okay, so that kind of started 2018, I think, was the first one that they published. So we had kind of built some mechanisms as part of our prototypes, but never really went far with it. But what if we could kind of go all in on that and see, hey, what is it like to build one of those? So we kind of set up a new fall system here where we said, all right, we're going to build an off-season robot. And one of the big things that we wanted to do with this was, one, learn something new that we hadn't done, but also use this to figure out how much we could actually build in a build season. So we took all of our new students and we were like, hey, we haven't built a good elevator in forever, so let's try and build a 2011 robot. Something that we had some tubes laying around. It's like needed a PVC pipe, and we're like, great, we can get some space here. And so we had the students work together to try and learn and build that robot, really kind of integrate. It was super simple. It wasn't, it could score. They actually managed to get an autonomous mode on it. It was really, really exciting couple weeks. But really, one of the hardest questions people always have is like, how do I know how much I can build? How much can I take off in build season? So if you spend from Thanksgiving to Christmas, which is about 6 weeks, and say, hey, let's try and build this proof of a concept robot, we'll give you a good idea of what you'll be able to get done in January. The upperclassmen would start designing and building prototype mechanisms. So they're like, hey, let's figure out, get a quick launcher that we can get together, have it just be zip tied together so we can figure out what launch angles we want, try from different spots, kind of standard stuff going off there. But we had our new students, all of those freshmen and everyone else, try and build an EveryBot. And then they would kind of learn, all right, here's where we can pick up game pieces, here's how the robot can kind of come together. And then as they picked up and applied those skills, jump onto the 1153 robot and put that together. So as we're kind of doing that throughout 22 and 23, we really, sort of began to really understand what our team capacity was. We kind of knew, yes, you could kind of build robots with about 16 students, keep them all really engaged as they go. For all those newer students that came in, we found that they really could quickly appreciate what things are being used for. When you try and get a student, you're like, hey, we need to build a max planetary gearbox. Hey, we need to build, we need you to melt together these pulleys. Hey, we're 3D printing these parts. They're like, I don't get what they're used for. You're not going to see that in real life. But when you go, hey, here's a released video of an EveryBot. Here's like this robot that we're building. You're going to go, you're making that, and here's how it goes together. and it all kind of getting put onto that robot. Related to that, the time commitment could really match whatever the students were looking for, rather than try and force everyone to come in and say, hey, we meet on Monday, Wednesday, Thursdays from 6 to 9, and Saturdays from 1 to 2 late at night. It's sort of like, oh, I know if I come in on Monday night, we're going to be building the EveryBot intake, and then we're going to be wiring the EveryBot intake, and then we're going to be programming the EveryBot intake. So if I'm going to come in on a certain night, I know exactly what I'm going to be doing. I can commit or say, hey, I don't really care about building it, but I want to wire it and program it, so I'll skip that night and come in the other 2 nights. And then as soon as you get them kind of coming in, they start getting hooked and start seeing those parts, and then they want to be in on more nights and start kind of having those sparks, having that fun. However, it's a lot of effort to build and maintain 2 robots. Luckily, for those first 2 years, we weren't trying to maintain them as competition ready, but we learned a lot about how to, there is a lot of wear and tear, especially when you're saying, all right, everybody, on 11/19, or every freshman, you're going to drive this robot for 20 minutes and get comfortable with trying to pick up game pieces and really appreciate what's going to happen at the competition. We find that students have a lot of opinions about how easy or hard a game is when they are just watching it, and then when you give them a robot and you're like, hey, go out there and you try and pick up that game piece from across the room, they have a lot more empathy for how hard they can make. And it also helps them be like, oh yeah, we do need to make sure we design this robot with a certain type of acquisition zone to grab game pieces or do what they need. But students also get very attached to their robot. All of our students there are affectionately around the 23 EveryBot, Helga, as they called it. They started to get really attached and are really curious about, like, hey, we really love this robot. How would this robot go? Because I think most of you are from New England. We could kind of how it would hold up in competition. So we have our 1153 robot that exists for that year, and I mean, we absolutely Taylor Swift it there. Full 22 going on both wins and losses. But very exciting for me. But for the students, that's like 22 defeats, and they're like, oh, we just had really great 2022 season. I don't know what we do. They're watching other robots, and they're like, oh, hey, the Grease Gladiators built our EveryBot, and they're 33-9. They're having a great time. They got multiple banners this season. So shout out. They really cooked with that EveryBot, and it made everyone on the team really be like, hey, I bet you our freshman bot could do just as well as the upperclassman bot. And so with that, we sort of decide to just go all in, on creating it. We've been building prototype robots and extra robots and spares and everything else. So we weren't too worried about building up that second robot and going there. And then we're like, hey, we don't really want to be the last team from New England to qualify into the World Championship. Like, it's fun, but we went in 2022. What learning experience are people going to get out of that when we could take all of that money that we need to fundraise to send the robot and travel down to Houston, Texas and everything to really just kind of set up and buy tooling, pit supplies, all sorts of second stuff to make it so that robot can leave our practice space. So why do we have kind of 2 teams? In summary, was to, one, kind of allows more students to get hands-on with the robot. We need to build twice as many things, and so that means instead of building 4 swerve modules, we are building 8 swerve modules for students. We need to maintain, we can have multiple robots be running autonomous modes at one time, so you can get more people programming and running their code, especially because simulation wasn't as great as it is now. Additionally, you have program flexibility. So we set up, and our 2 teams really have 2 very different goals. 1119 exists to have people capture that spark and just get excited about engineering. Or maybe they're a student who wants to be involved in the wrestling team, or they're doing the musical, and they're like, hey, I can only come in on 2 nights a week. I'd either come in, know what I'm working on, and just keep going with it, because like 1119 we'll kind of get into has a very structured robot and structured build. Whereas if you skip a few nights on 1153, you might discover that there's an entirely brand new robot that has been CAD'd and designed, and we're building that one now. There's more opportunities for, like I said, there's kind of twice as many everything to go. About that, but also by bringing, instead of just building them, which we could do, we get double the amount of competition opportunities for the students. So that's now twice as many students who get a judge interview to talk about their robots inside the pits. You have more students who get involved at coming up with match strategy, because instead of doing 12 matches, you're doing 24 matches. And so you can start to have different students say, hey, I'm going to lead up match strategy for 1153, I'm going to lead up match strategy for 1119. Or maybe the two robots are very different. Our 2024 robots ended up being that the Pup Cups could do the amp and 1153 could just score in the notes. And it worked out great in our fantasy world, in our head, where that was sort of what the two robot archetypes were, but not so much in real life. But it kind of gave some different thoughts to what they did there this year. 1153 was an algae specialist. Pup Cups could kind of just score a lot of coral and get those things worked out well. So you could do different match strategies, and twice as many chances to have people go interact with other students and everything else that comes with the competitions. So going off that, how are we organized? So students are generally split by grade in our program here, but ultimately the students get to choose what team they want to be a part of. So this past year, freshmen and sophomores generally made up 1119. We had about 20 of those students there, and the juniors and seniors, we had 16 of them this year, made up 1153. We have had students, Walpole runs a STEM academy, so there are engineering courses that are offered during the day that, in order for us to get some school funding in space, FRC is part of the curriculum. There's always kind of been this divide of the students who are working on stuff in the classroom. How do they pair up with this robot that's being designed and built and done with everything outside of those school hours at our after-school meetings? So, any juniors or seniors who are in those elective classes and are just kind of earning that STEM Academy credit and earning spots on the team there, they can kind of be a part of 1119, where it's like, oh, we need to do a little bit of change of a little bit of this design here and there, or we need to create, CAD of the field stuff, or we want to plus an extra mechanism onto the 1119 robot. We can offer that as that opportunity and have it not compete with this other robot we're trying to build on 1153. And it's similar to that, we talked a lot about strategy, a lot of times the upperclassmen who have gone through and been the scout leads or the strategy leads, sometimes they choose to want to lead strategy and stuff for 1119 versus 1153. And sort of for new kind of this year, we're running into our first group of FLL students who have started coming through our program. Our FLL kind of ends at 7th grade, and we have this weird gap year of 8th grade. What do we do with? So we're starting to get them involved. We're going to try and slot them in on the Pup Cups as kind of like come in on Saturdays for 1119, get a little bit of that taste, come to the competitions, and then really start trying to jump up from there. Our mentors, as we mentioned, we have about 14 mentors that work with both of us, both teams. And so the mentors will jump between both 1153 and 1119. The two robots are never in the same spots at the same time. And so there's usually, we can start manufacturing stuff right away for 1119, so kind of our shop people might start off there, while a little more of the CAD mentors might be down, might be able to assist more with 1153, and then it kind of swaps as we start trying to build 1153's parts, and then 1119 wants to try and iterate or change some designs, based off of how things have worked on our practice field. Generally, as the season goes on, certain mentors do slide into being more 11-19 focused or 11-53 focused, but we let them kind of go between the both. And then just for consistency and rules purposes, all of the students and mentors are on both official rosters. I'm sure if you actually look at them, they're not a one-to-one match, but that's just because First website is terrible. But so if somebody has not applied to both or didn't accept the invite to the other team, whatever, it's good enough. Everyone's on one of the two. So how do we start with off-season trainings? So for returning students, generally we'll start up in a couple weeks, middle of August or so. And then for August through October, they are maintaining last year's robot as we go through off-season events, trying to get them go through that there. If things are fragile or need extra parts, we might build some spares, and also just get people kind of used to working on that. And then in November, we'll kick off what we kind of call our mock build season. So we'll build a robot for a past game. It used to just be I would pick whatever game I could find game pieces laying around in our venue for. Now that First generously offers us to pre-order game pieces, I can be a little more strategic in what sort of games I force them to build. So last year we knew there were 2 game pieces, so I just picked the last time there was 2 game pieces. So we did the 2019 robot build last year. This year, since I had to buy, increments of field pieces as 1/6, and we have a ton of fuel cells. Thank you, Andy Mark, for packing material. They're probably going to be trying to build like a 2017 hopper, and they all asked me to build a turret, so I guess we'll finally build a turret. I'm pretty staunchly on once you've built a swerve robot, the robot's on 4 turrets. Why do you need another turret? But this is me being software pilled instead of mechanically minded. And so they'll come in and they'll work on that. For new students that come in, I know there were some questions about what kind of projects do they need to build. So they'll start right after Labor Day. And then in September, I noticed I don't break this down by grades. It's more returning versus new students. If you're a student who discovers the robotics team as a junior, you're still going to go through all the new student stuff because we always do have those later students come through. But September, we'll do shop and safety certifications. So everybody kind of comes in. We walk through stuff around, hey, here's how do you turn a robot on and off. Here's how you enable and disable a robot. Here's how to use, these, the bandsaw, or here's how you can get certified to use like the drill press or the CNC. Kind of go through those, get used to our area. And jump through from that. Then starting in October, we try and take them through a lot of what I would call kit builds. So we take apart swerve drive modules and we put them back together. So we have a set that's just used for students to get comfortable at learning how do those come together. They'll wire up a control system on that. So first they disassemble and reassemble that. Then they'll put those control systems together. The programmers will then work to try and reprogram this robot. It's great because we just have set code that is working swerve drive code. If they ID'd everything correctly, they wired everything correctly, so we can very quickly figure out if it's a code problem or if it's a hardware problem. And we just get them really comfortable kind of with those builds. And then, it does change up. Sometimes we have them work on different steps. This year, I decided I was going to watch way too much YouTube. I found a bunch of the Crunch Lab stuff from Mark Rober, so I purchased that subscription there. And then out of the 8 boxes we got, there was 4 interesting ones that we're going to try and walk people through as builds. So he has a frisbee launcher. He's got these meshing gears that you can use to draw shapes with a pen. There's a conveyor, there's a conveyor belt system that moves a duck around, and there's one more. So we're gonna try and 3D print some parts and then just have people CNC cut out the other parts out of MDF board and try and just pirate stuff out of Crunch Labs as some of our smaller projects for this year. I know there were some questions in the last room about what small projects do you do, so that's what we're lined up for this year. And then after they're kind of comfortable coming into all of this, they'll jump on in December as part of that mock build season. So, it kind of allows our upperclassmen students to spend November CADing designs, maybe coming up with a few prototypes, seeing how those all work. And then once there's actually actionable items, you can't, as kind of mentioned, it's hard to tell a new student, hey, we need to build a hopper, we need to build an indexer, go. If it's a lot more simpler, like, hey, we've got this design, we need to cut these pieces of polycarb, we need to wire up this gearbox that's going to spin this motor. They can kind of get that, and it takes their knowledge they got from those kit builds from beforehand and brings them back in. All of this stuff generally happens. We'll have a Monday night meeting when everybody comes in, and then you can either come in on Wednesdays or Thursdays based off mentor availability and what the student availability is. So generally throughout the fall, we have people coming in 2 days a week. Upperclassmen students who are obsessed with FRC, they come in all 3 days, and it's great because we do need that. But the minimum expectation we have is that they come in on those 2 days. And then the third part there, on those Monday nights, is that's where we do a lot of team building exercises. All of our students do all of our community outreach events that we have to attend, and we ask all the students to assist in fundraising, because obviously it can be very expensive to run one FRC team. It's very expensive to run one FRC team with 2 registration costs. But we'll get into finances a little bit later. So one of the big things that we like to really try and emphasize here is that because Walpole's school mascot is the wolf, we like to try and make sure that we are all one wolf pack. So, flashback to the hangover days here. Team building is one of the really huge things that we want. We want everyone to really feel and act as if we are just one robotics team who has just happened to enter 2 robots into the competition here. And so, what does that mean? That means that, as I mentioned, everyone goes to our community engagement events. We go to the local farmers markets. We go to the Walpole Day event. We go to, the Thanksgiving Day Santa Parade. There's like pumpkins in the park. I don't know, whatever your random stuff that your town is doing here. We have the Lego, a lot of Lego work to do at the library. We try and ask anyone who's a returning student to help out with those Legos. So new students or any of the really younger ones, you do need a little bit of an age gap there. But we also want everyone to kind of, a few of the students commit a lot of time to it. Other students kind of just come in one session, but that can be sometimes great because I know how this group needs to get some programming help. We'll have some of the programming students come in tonight. This group's having a hard time getting this motor to spin, or they have the wrong kind of torque on their Lego thing. We can have a mechanical student help them out, or sometimes people are just there to listen to them talk about their projects. It's all important there. And then fundraising, everybody helps us apply for some grants or to cover it some other way. Additionally, we try and make sure that underclassmen are paired up with an upperclassman throughout the off-season as a guide or mentor. So after you've picked what you're kind of interested in, I'm a CAD student, we'll find you an upperclassman who's in CAD that you could ask questions to. Or if you're a programmer, who can you talk to there? Just to sort of be that guide, that person they can ask questions to. Sometimes they're more willing to ask questions to other students than they are to adults. So I just really want to make sure that there's somebody they can go. And the last big thing there is everyone's expected to jump between the robots and assist when possible. You'll kind of see that the 1119 robot is done right at right around week 0. They've just wired up their robot probably twice because they messed it up the first time, and it was a great learning opportunity, and then they did it again, and now 1153 needs to get their last part of this robot wired so they can quickly jump over there as other people are trying to jump around, because you don't want to burn anybody out if you do have 15 people on each team. If you can kind of spread that workload around, or as people find things they like to do, give them that chance, because we've got 3 robots that we need to wire up or do whatever with. So kind of going off of that build season, so 1119, we always build a public robot design. So we don't commit just to the EveryBot. Sometimes, the EveryBot ends up being closer to like the FRC kitbot, and we kind of want to push ourselves a little bit beyond that. So we kind of look at all the robot in 3D designs, and they pick between there. We let the students decide which one they want to build. It has a very structured build season schedule that I will jump into on the next slide. But we really love it because the students can really quickly understand and visualize what they're building. They see the kickoff video happens, they see what the kitbot is building, they do that, they get their swerve, we look at what the requirements are for this year, we start building their new swerve drive base for them to go, and they know, all right, I'm building this robot that needs to drive from this part of the field to that part of the field, and then there you can see all the robot in 3D videos, and like, oh, that's really cool, I want to build that. And we can say, great, we're going to go build that. It's very easy to sell to a parent or a new student what is happening each night. I don't know how frequently it happens, but after we tell parents that, hey, these students are going to be here like, 20, 30 hours a week, they're like, doing what? And you're like, well, it's a lot of work to build this robot here. And say like, we make it so that way we can tell the parents, hey, if you come in on this night, we are wiring up these swerve drive modules. You can then ask your kid when you pick them up, how did it go wiring these things together? Or I don't know what a swerve drive is. You just built one. Can you explain it to us? And it really helps set that system up. And then realistically, we want everyone to just feel really accomplished. You want your students to kind of get a win as soon as possible, especially if you're a new student. And so you're not going to want to come back if you just spent 20 hours this week and you made no progress because you're making progress when you decide that this design's not right. Like, it's not a negative experience to design, build, iterate, and say this is not the right thing. But sometimes if you are a freshman and you just put 10 hours into building this catapult and it's just not going to work, it can be very disheartening if it's not going to go places. And so kind of knowing, oh, we're always going to build this, we're not going to pivot to a new robot design after some new post came out on Discord at 3 o'clock in the morning and then students woke up and skipped class to CAD something brand new. You just want them to see, oh, hey, this is really cool, but then they will eventually get a chance to see what kind of buy-in is required for that high-level play by the time they become those upperclassmen. So what does the 11-19 build schedule look like? Week 1, we refurbish, we build swerve modules, we image everything, and we try and get a robot driving. So by the end of 1 week, we've got a robot driving around that honestly either team can use for autonomous planning. Getting your robot to drive from point A to point B is always great. Get that where you need to go. Week 2, we know we're going to need a bunch of max planetaries. We are thankfully out of the versaplanetary game at this point. Too many just Ziploc bags of gears everywhere. But build max planetaries, start 3D printing a bunch of pulleys of different sizes that you're going to expect. 1153 at this point is probably going to be doing something cool, like trying to shoot an algae ball like 20 feet in the air. So you're like, oh, that'd be really fun. Let me try and jump on, help out with that as I kind of learn these things. And then we give them homework each night to be like, hey, tune in to this robot in 3-day team. Start writing down what you like about that robot, what you don't like about that robot. Because unfortunately, Martin Luther King Day is always week 3. And that's when the EveryBot comes out and the RevRebot's finally published. And really, people are willing to give you their CAD that you can start building off of. So after we stall a little bit in week 2, all of the students all get together and they vote. They chat it out over, hey, what are the pros and cons of each of these robot designs? We want to build this one, and sometimes it takes different lessons from last year or from this year, or what they're kind of seeing 1153 do. But they decide, they vote, and then we choose, and then obviously it's never going to be a perfect fit. The EveryBot is usually on top, is usually on top of like the kitbot. The RevBot uses the Rev swerve modules, and we've got all SDS swerve modules, and so there's always slightly different clearance stuff. So we get a bit of CAD opportunity for those sophomore students to start modifying the designs to kind of fit what we have sort of laying around. In week 4, we try and have our first mechanism really built. Typically, We'll have them focus on how do you get the game piece. That's usually the first thing you want to make sure you do in a match. You can drive, we got that. Next step is getting next game pieces. Then week 5 would be build the scoring part of that robot. And so sometimes, for this year, the mechanisms to get the algae or get the algae off the ground or get the coral, not too hard, you get that together, but then you spend a little bit more time building the elevator to be able to score it. And then in week 6, you build the end game mechanism after we've kind of figured out whatever we want to do with that there. And then from week 7 on, so we've kind of hit that week 0 point, it's kind of now getting ready for competition. We want to build spares. We're having everyone on 11-19 drives a robot in the practice space. Everyone's kind of working on that stuff so we can see what breaks, what do we need to iterate on, what enhancements do we want to make, knowing that, seeing how the game works. And importantly, if something overlaps with 1153, we start getting that buy-in to share that knowledge, share that parts. So like for this year, both of our robots have the exact same climber, and so all those students could go jumping back and forth between those two teams to drive in, iterate, see which one had the best grippiness on the cages, who got the, obviously the weights were a little different, so they got to learn all about those fulcrums and how that goes. 1153 sort of has a more standard build season that people go through, so we spend a lot of time the first half of the first kind of week just analyzing the game. I know it's very important to have everyone read the rule book, but if you ever try and get in the weeds with a freshman on what is explicitly legal or not legal, you'll watch their eyes glaze over very, very fast. And so if you can instead have them go off and build a swerve drive, they'll be a lot happier than sit in the room and argue about how, what is the scoring optimization of getting 12 L4s versus getting 6 algae scored and 12 L3s and, doing decision matrices. But we set, so then we analyze the game, we build those requirements. The big thing is we set weekly goals. So every Saturday at dinner time, we set, here's where we got this week, here's where we want to be at this time next week. What do we do to go from there? Constant prototyping, iterating on designs. And the students are just really engaged with the engineering design cycle because they've already built up a lot of the basic skills from their first 2 years on 11-19. So team roles always comes up a lot. Where do people fit in? How do they go? And so generally, we like to try and think of it as new students are supposed to just be there to explore their interests, try out different areas, try and just learn as much as possible. Second-year students have a chance to step up and lead the groups. We sort of have got this new opportunity where everyone can jump up and go. Students can then kind of make their choice. Do they want to be a lead designer? Do they want to just be a manufacturer? What do they want to build? And with multiple robots to build, there's plenty of leadership roles or manufacturing roles. So everyone can kind of fit whatever they're looking for on the team. So if you've got 30 students, sometimes you've got only a couple of students want to lead things. That's okay. Other times you have a lot of people want to lead things. There's a lot of those opportunities. I keep all of it organized by spreadsheets like this. So we try and brainstorm up all of our ideas so we can say, hey, here's small breakdown tasks that they can do. The students all get to go in and edit this. We have one for 1153 and 1119. So they can go and put their name on, or we assign it to them, and then it becomes their responsibility, and then they can update it to being, either not started, in progress, blocked, done, and we kind of go through there. I appreciate that the programmers have left comments as the only thing that they haven't finished yet for this year. Always very, very accurate. At competition season, we generally try and compete at the same event just for logistics. It's easier to get everybody to the same events. Students share, they scout together and they share the raw data, but because scouters and people end up like the leads of their strategy, like their own Tableau dashboards, their own Google Sheet views into the data, they all get to kind of go off and build their own and test their own conclusions for the match, and alliance strategies change. A big thing, though, that we do is 11-19 has a very rigid schedule. So everyone's going to have 2 hours in the pit, then they're going to have 2 hours in the stand scouting, then they're going to have 2 hours of free time to go have fun, complete scavenger hunts around the area. And it's all just very set. And if, if someone's in the wrong spot, we're just like, hey, you're supposed to be here right now, you're supposed to be there right now, you're going to have your time later on. And that's also great because 1153 has assigned roles to everybody. You're the driver, you're the pre-match, you're the post-match, you're the repair for when this system breaks, you're the repair for when that system breaks. They still have to go out and scout with everybody. That's in order to get the data. They also have to scout and get it. But it's a big thing to make sure that goes. And we've seen that since giving everyone those rotations through the pit, there's no longer those hard feelings of, the pit seems really cool, I really want to be there. A lot of students find out it is super stressful and not very fun to repair the entire robot in 15 minutes. And they also get a strong understanding for when you're in a 10 by 10 space. That space is nice. Only 1153 does Dean's List, Woody Flowers, and Impact, just to keep all that stuff clear. I know we're kind of running out of time, but so we do send both robots to district championships if they go. We kind of feel that if a robot qualified for DCMP, we really want to celebrate their efforts and on-field and off-field successes at going to the event. They sort of earned their right. They put in all the time and hours as anybody else did to put their robot on the carpet, and having kind of built robots that stayed home. In the past, we've kind of found that it's a really big celebration of their success to have them come to the district championship. If only one robot qualifies, though, all the students still come because we're all one team. They all come to the district champs. And then for world championships, it's expensive and it's a lot, so we just take 1153, but we do bring students from both teams. If you don't bring any of the freshmen and sophomores, you're not going to have people really ready to go. And 1153 has got those assigned pit roles, so the 1119 students get the time to go obsess over 254 and 1323, go hang out in all their pits, go attend a few conference sessions. So like they've got some scouting time, but we're not good enough to scout at Worlds, just being honest. So overall, different robots have different goals, so it allows us to really apply FRC to wherever the students need. So if the students want to just learn how to use a CNC machine, they want to just build stuff, we've got that. If they want to build a hyper-competitive robot, we can offer that. So we can kind of meet those students where they are. You get more interactions. There's twice as many students that have to go and do strategy meetings in pits with other people. There's twice as many people talking to judges, twice as many people driving. 1119 does multiple human players. I'm very adamant that your driver and operator need to be the same at all your competitions, and throughout the same, or at least at the same competition, need to be the exact same. We have had them switch between events, but we can kind of get more chances for that. More people get in the pit and see what that role is like and how exciting or unexciting it is for your personality type. More leadership roles. In general, students just figure out what parts of FRC they love and can really just dive in and do that. They get those opportunities. The cons, though, people get very confused at the event how there are 2 Walpole teams. You have to explain it to every set of judges that comes by. And sometimes they get it, and sometimes they don't, and it's okay. We're all about just more talking to judges and explaining things than trying to win a bunch of awards. We explain a lot about what the difference between the Pup Cups and 1153 are, and how one's more about kind of learning skills and one's about high competitiveness. It is twice as many robots to maintain, and it's just more of everything. It's more space in the trailer you need to have. It's more adults you need to monitor the situations. It's more hating the match schedule that comes out. It is more everything. So yeah, so our future pipeline, just because we know, we do FLL in order to get this. We went to Champs in 2022, and FLL was there, and we're like, great, if we don't want to have a great reset after COVID, because that will never happen again, how do we do this? So let's come back and do FLL. We set it up at the library, because Walpole has got like 5 elementary schools, and it was too hard to try and get buy-in from one school, so one central spot they could do, and we've been able to grow that up in terms of number of teams. And yeah, a lot of our high school kids are expected to help with both teams, and our first 8th graders are just starting to hang out at our shop this summer and getting ready for the events there. I chatted way too much earlier, but for finances, we try and reuse everything for 1119. So everything that used to be 1153's prototype or 1150 or we've used in past seasons, they get to use it. So everything, motors, modules, sensors, cameras, everything's kind of all reused from past seasons. But we do set a budget for $2,000 each year just to buy new materials for that. 1153 does reuse stuff from time to time. The brushless motors are great for that. It is expensive for registration. It's $10,300 for 2026. The school will cover one of the teams. The nonprofit that we runs 1119. It's also how we can get around with it being community-based, technically community-based rather than Walpole High School-based. So if we did have people who were in Walpole but went to other high schools or did other things, we could sneak them into FRC that way. But we do keep a shared list of FRC grants that are available and apply to them. So I've started to pull the one from this year. So we've got a list of every grant that we can find, what company it is, what notes we've got. We've got documents that have commonly answered questions to them for both teams, and we assign them out to each student. You have to apply for this one, you apply for that one. And so generally what we do is we put 2 students on each one. We have a junior go with a freshman, or junior, senior, get paired up with a freshman, sophomore. They go off and they fill out all the forms, and then they get some mentors to come over, and then the mentors hit submit after they've proofread and verified everything in there. And I'm happy to, if you hit me up, happy to send you a copy of list of grant companies that you can find. And so just sort of parting words, because we got about it right here. I would say consider building a kitbot as an entry point. Juju kind of mentioned this. If you have freshmen you don't know what to do with them, have them build the kitbot. It's fantastic, especially because next year there's going to be a brand new control system. So just reuse this control system. You all have extra Robo-Rios and PDHs and everything will be laying around starting next year. So if you want to start planning for that, try and just build that kitbot or think about how you can use a kitbot. You don't need a ton of people to run the multiple teams, but you do really need to empower the students to make sure that they can run off and make decisions. And you also make sure that you have them jump between teams to prevent burnout. And in general, 1119 is all about learning and having fun and getting that spark. And then 1153 is about being competitive and trying to win events. And so students kind of get to self-sort between those based off the experience they want to have. You can find me on the Mentor Slack on Chief Delphi, and you can also email us at Walpole Robotics. I know it is right about at time, so I'll let you go get a break, but I'll also hang out if anybody has questions or if people have questions they want to shout out now. Happy to go. Yes?
How do you handle shop time and resources?
So we have one room. So we have like 3 spaces that we're allowed to build in. So we have a machine shop, we have a clean assembly room, which is like a classroom adjacent to the machine shop, and then we have like a practice field, half a practice field kind of a space that the programmers work in. And what we do is similar. Basically, we just only ever have maybe like 8-10 kids, about 4 of each in each night. Generally, students come in on set nights to come and build different things. But we maintain, whenever I get to, I probably went past it. The spreadsheet we have a spreadsheet that everyone gets to put work in that says, hey, these things need to get 3D printed on printer 1, printer 2, printer 3, printer 4. These need to go on our CNC. These need the lathe. These need the the Bridgeport. And so there's extra columns in this spreadsheet. And then students go through that, and then each Saturday, the mentors and kind of the team captain of 1119 and the team captain of 1153 will all get together and we'll try and prioritize what things need to get cut when. Generally, if it's earlier in the season, we give it to 1119 because 1153 probably needs to do another CAD review on it. And then later on in the season, it will kind of be like 1119 is still working fine, but 1153 really needs this to find out if this new iteration actually works. It's not quite last year, so we'll keep last year's around, but like 23 has been disassembled at this point. So we'll keep 24 around for a little bit. And then we'll probably, honestly, like we'll probably take the swerve modules off of it and then just put it on like a furniture dolly because it can shoot discs, and so that's very exciting. So we don't have to maintain the 2013 one to shoot discs. But we'll probably take the modules off sometime as one of this fall's projects and try and reuse that. And then if we need to take off any electronics from it, we can. But yeah, we generally try and keep robots around, 1 year, maybe a year and a half, and then we'll start taking them apart. Yep.
So when you were thinking about sitting at the second team, did you consider doing FTC instead of varsity?
We didn't have a lot of great experience. We used to have FTC as in high school. We had that ran as like the engineering classes there. We just didn't really like it, mostly because it runs at it's a different season for it, and so it's very annoying to try and like get them on an FTC team that will start building their robots in October, November, and then they're still competing in January, February, and then their competitions kind of end there, and FRC is still going on. It was always hard to get the students to mix between the two, so we just thought it was a little easier to start building kit bots, and then the students were like, can we compete with the kit bot? And we were like, yeah, this seemed probably like a better inspiration worth of money than flying everyone down to Texas to go unpicked. Yes?
When you apply for a grant, like one grant agency, do you apply twice for the two teams, or do you only apply for one?
Depends on how the grants are set up. If it's like a local business, we just apply as like the Walpole Robotics Foundation and have them just donate the money to the overall robotics program. If they are somewhere that first advertises, like Gene Haas is like, we want to support first teams. Argosky is like, there is a grant that we will fund you for your first 3 years. We do apply for those for the teams directly. And that's why some of the ones, like we'll see that Gene Haas is like an MO as the Society of Engineering has like 2 slots. So some of them go to 1, some go to 2. All right, I think they need to get set up for the next presentation. But. Yeah.